everything that's going on in the rhizosphere. Again, we're leaking stuff. Yeah? Your plants have amazing capabilities. They're going to leak acids like chickpeas to get the phosphorus out. They're going to leak siderophores so that they can chelate the iron and the zinc and the micronutrients. They do all of these things. That's why biodiversity is important. Next. Yeah. So, corn. If it's actually attacked by an insect larvae, it starts producing chemicals that actually change everything that's going on in the roots. Lupins are really cool. If you have slightly acid soils, you can probably grow lupins. And lupins have these cluster roots. So does rooibos tea. And they pulse out acid so they can get phosphorus. It's really cool. Plants have the capability. We just need to marry all these plants up together and get them all being compatible, and who knows where we can go next. There's actually a couple of farmers in outside of Yorkton, Saskatchewan, that are playing with variable cover crops. They're growing different plants in areas according to their soil test. So we actually map the field soil survey, and then we're growing plants in different areas. They're grazing. So that we can actually affect like soils that are not giving us phosphorus. We've got buckwheats and we've got corn and some warm seasons in there. And then soils that have other problems, we've got other plant mixtures in there. So in one quarter, they've got all these different plants and they're all seeded according to what they need in the soils. Next. Because of this. So you see the above ground, we want that because we're going to compete against things, but we also want below ground changes. Yes. Anytime you go to a field day, you should get a pit. Have a look. I mean, when I was in Germany at the DSP field day, it was the mother of all pits. It was the length of this room. And every one of the soil, every one of the plants that they've grown and all their cover crop mixtures and everything had a pit across them. And we had like 300 people and they were all down in subterranean looking at these roots. It was fabulous. Yes. Green plants. The more often we can grow a green plant, the better, because it means that we keep things going. Because green plants leak a lot of very available carbon substances, amino acids, organic acids, and sugars, and that's what really feeds the rhizosphere. And that's what feeds the majority of the soil animals and soil biology. So as long as we can keep a green plant, we should try. Next. This. John Neal, actually the lab I was in Lethbridge, John Neal had actually been in. John wrote this paper. I think this is seminal work, and I don't think we use this enough. Root exudates can actually defend or they can attract. I've already talked about all the things they can do. Well, we should be taking advantage of it. We should be looking to nature again and saying, how do I use what's going on here and take this into my field? I know I'm going to be managing things because we all have to create a certain amount of will, but I think we can do it and actually take from nature and learn some lessons and make it better next. So let's look to nature for inspiration. Next. Diversity. Look at a native pasture. This was really interesting. In the U.S., they have a program called CRP, Conservation Reserve Program. It's a terrible program. It should never exist, but never mind. And we had one farmer, a grazing farmer, and he'd done all this CRP. And then he had this fantastic native prairie, shortgrass and native prairie. And we walked through it, and he goes, wow, look at the diversity in there. Wow, look at this, look at this. I said, yeah, and look at how short it is. Yeah. He's been seeding everything that's really high, but the native prairie was really short. It had more diversity, it had more dicots, it had more broadleaves. And he's like, wow, why did I do this? And I was like, well, because the government paid you to do it. Yeah, that's a good point. But, it was coming out. He said, what should I do next? And we're putting grazing trials on it. The point is, have a look. If it doesn't look kind of similar to what you need, then don't do it. The other reason that we want to put legumes in mixtures. And this was an important point, because we all hear, oh, I need to have 8 plants in a mixture, or I have to have 12, or I have to have 25, or I have to have this. No, the key thing is that you have to have some legumes in the mixture. And in every native system I've been in, there are legumes in nature. So we need to have it, we need to look to those short legumes, the lentils, and the subtropical clovers, and things like that. Next. Oh, I need my next person. Some of the roots and different ones. This is woolly pod vetch, and I really like woolly pod vetch. It's very drought tolerant. This one is arrowleaf clover. Here we have fava beans, and then this here is sun hemp. Don't try growing sun hemp. It's not warm enough. Next. I just wanted to show, this is one of my mixes here that we're growing in fava beans. When you've got this much shoot, look at the roots. It's a great plant. Next. Don't get disease when you have things all mixed together. You know, it's all about what perception is. It looks terrible, and I mean, I hear people, you know, oh, we go to these field days. I had a cover crop field school this year, and we had all these farmers walking through, and they go, this looks like crap. It just looks like crap. And, you know, there's all this stuff in between the rows, and there's flowers, and, you know, and some of the women are like, oh, those are really nice. And the guy's going, oh, it's just crap. You guys spray this. And we're going, no. And we harvested it, and we actually out-yielded everybody in the area, even though it looked like crap. So, it's, you know, that's why I say make informed decisions based on science, not just, you know, oh, this looks like crap, it's all about in your head. No. Actually, Dave Brown, who's a farmer outside of Bismarck, North Dakota, somebody asked him, he said, well, you know, how did you change to this log grazing system? And how did you get rid of the compaction and all those other issues? And he said, well, first thing I did is get rid of the compaction up here. Once I got rid of my compaction, then I was fine. Next. I have water use efficiency. Well, I live on the prairies. No, I'm going to do all this. It's going to eat up all my water. And okay. So here's common vetch. Next. Here's when I mix common vetch with all these other plants. Gosh, what happened? Water use efficiency. I'm not sucking the water out anymore. I can't tell you why. This is the factor of, whoa. When I mix things together, all of a sudden 2 and 2 don't equal 4 anymore, and I don't know why. And I'm a scientist, but I still can't tell you why right now. All I know is that this is the data, and it shows me that when I put mixtures together, they don't use as much water. Now, I think it's because of hydraulic conductivity, because my deep roots feed my shallow roots, and they're all connected, so they're all sharing the resources. And I think that's why it works so well, is because now we're sharing. Now we have a network, and we're all sharing. You know, it's fabulous. Next. Another one, different mixtures. This one has a lot more brassicas in it, so we're using a little bit more. But again, mixtures don't behave the same as individuals. When they're all in a mix and they all get along, things happen that it's marvelous. Next. There's a lot more that we need to do to understand this, because we just don't understand when we put the mixes together what happens. But we know, if we think about nature again, that prairies survive, forests survive, they had high productivity, and they never really had breakup, and they were all no-till, and it was still cycling. Thunderstorms, great source of nitrogen too. I mean, it's phenomenal how much comes out of that. So, we'll go to the next one. Here's some more chickpeas in a mix. I actually am putting them in my mixes now. There's my fava beans beside it, so another little experiment. Next. Just more roots. Next. I think fava beans, if you're really lucky in Saskatchewan, you've got some new small-seeded varieties that I think are going to be really great. Next. This is really important. See how beans have 4 colors? See how peas have 4 colors? That's why you're putting leggings in. But look at white clover. It's all nitrate. I don't want all nitrate. I want 4 different nitrogen compounds because I don't want everything leaching. So let's use these plants. Let's take advantage of what they do for us. Next. And see what happens. See these mixtures. I'm not going to explain the PLFA too much, but you can see I don't want number 20. Number 20 means that all I have is actinomycetes, but I may want the number 20 if I'm having a problem with scab in my potatoes. These mixtures are changing things. When we start mixing plants, when we start using plant properties for what they can really do, now we can actually start changing the microbial community and using that against our problems as well. I love it. Next. This is DSB, Rogan is rye. This is with spoke injection. Pultan is spoke injection. This was rape mixed with clover. This is this was maize, one of the maize cover crops. This was maize with mustard, and this was I said unknown here, but this was actually Maize Pro, which is another mixture. And what we see here is that we don't want I want my bacterial and fungal ratios to be in that 10 area. So I like these ones here. When we did the spoke injection, even under 11 years in no-till, I really didn't like it. This is a lot of bacteria, and not what I wanted. And it's nitrogen. It's something about nitrogen. It really backs out the fungi. We're seeing some real problems, and when we really knock back the nitrogen, the amount of nitrogen people are using in their field, we start to see the biology come back. Nitrogen is toxic. Total PLFA is total living biomass. Look at continuous corn production. That's disgusting. Maize Pro, very nice. Betamax. Maize Pro is much nicer, and actually all original mycorrhizal, they were yellow. It was fabulous. Again, have a look here. Nitrogen is toxic. Go ahead. Mixes. This is forage mixes. So here's the last thing I'm going to talk about. How do we manage weeds? Grazing, integrated livestock grazing is your friend. And anybody who's integrated livestock has a huge advantage over just cropping farmers. Because now I can grow a cover crop and it pays. I feed my cows. If my husband hates it, I call these cows tools. And when I moved on to the ranch, I said, "Oh, honey, this is great. I have all these tools." My cows are tools. But they are, because I can grow cover crops. I see directly into our pastures. I tweak our pastures depending on what our animals need, depending on what's the problem. So I just take the drill and I just go right into the pasture, seed it in, modify the plant community to whatever I want. And we just don't have it. We don't use mineral. We don't supplement with anything anymore. Sometimes selenium, because our soils are just deficient in selenium. But, everything is healthier. And that's the key. Productivity is up. Animal health is up. I think our whole agro-ecosystem is up. We've created wealth for ourselves. And by the way, wealth is part of your agro-ecosystem health, because we all need a certain amount of money in order to make things work. It means that your community is doing better, you're doing better. When we talk about agro-ecosystem health, it has to be about everybody. It's your animals, your below-ground livestock, your crops, your community. Next. We saw this already. Just reinforcing it. Seed to temperature. Next. Because of these guys, too. These guys don't work at every temperature. We have a gradation of communities. We see animals, the bacteria and the fungi start, the earthworms come up at 5 degrees Celsius, and they start working, then they go down when it gets hot, then the mites take over when it gets warmer. I mean, if we let nature go, she'll use it.